Welcome to this explainer. Today, we're tackling a massive, often invisible tax in AI development, bloated context windows, and sky-high API costs. Honestly, if you're building apps with large language models, you know exactly what I'm talking about. Every single token counts, right? And without even realizing it, you might just be throwing money right out the window.
Okay, so here's our roadmap for today. We're going to cover 1. The context bottleneck, 2. Meet Headroom, 3. Smart compression, 4. Agent wrapping, and 5. Production. Let's just dive right in. Section 1. The context bottleneck, or, how to stop paying for redundant tokens.
So, I want you to imagine a world where a smart traffic cop sits right between your application and your LLM provider. Their whole job? Packing your prompts tightly together before they hit the open highway. Seriously, what if your LLM traffic was just automatically compressed? It would silently remove all that repetitive noise while keeping the exact meaning of your instructions completely intact.
The contrast here is actually pretty stark when you look at it. On one hand, you have standard API calls. That's basically brute force, sending your entire conversational history every single time, which, guarantees incredibly high token costs. But then, on the other hand, you have the Headroom Proxy. It uses semantic caching and intelligent multi-factor optimization to trim all the fat before your request ever even reaches OpenAI or Anthropic.
All right, moving on to Section 2, meet the Headroom Proxy, the standalone HTTP server.
The really crucial takeaway here is how seamless this whole thing is. Headroom Proxy acts as a standalone HTTP server that works across almost any client. You literally just point your client at it. Whether you're working inside Claude code, coding away with Cursor, using the standard OpenAI SDKs, or even building custom enterprise apps, Headroom handles the compression entirely behind the scenes.
And you get total control right from the command line. You can easily set up guardrails that fit your specific workflow. For instance, you can set a daily budget limit in USD, so no more surprise bills at the end of the month. You can also specify a path for detailed JSON-L logs, or, if you need to, just use the No Optimize flag to enable a simple pass-through mode and turn compression off for a bit.
Let's get into the real technical meat of this thing. Section 3, Smart Compression and Context, the brains of the operation.
So, this brings us to the Intelligence Context Manager. This is the brilliant default engine that completely replaces that outdated rolling window approach. For years, the standard way to handle context limits was just to aggressively drop the oldest messages first. But Headroom throws that entire concept out the window. Instead, it uses a totally new paradigm, multi-factor importance scoring.
Instead of just blindly tossing out old text, the system intelligently evaluates every single token. Sure, it obviously still looks at recency, but it's also evaluating semantic similarity, specific patterns it's learned via TON, error indicators, which, by the way, can be absolutely crucial for debugging, and even forward references. It basically figures out exactly what your LLM actually needs to solve the current problem.
Now, you might be wondering, well, what happens to the context that gets cut? Good news, you don't have to worry about losing critical data. Dropped messages are securely stored using CCR, which stands for reversible compression, just in case they're needed again later. If your conversation shifts and suddenly an old piece of context becomes super relevant again, the system seamlessly retrieves it. It's like a safety net for your tokens.
To be completely transparent here, if you really want to push the envelope and enable the LLML Lingua machine learning compression, there are some operational trade-offs to keep in mind. It adds about 2 gigabytes of dependencies, stuff like Torch and Transformers. Plus, you're looking at a 10 to 30 second cold start, and it eats up around a gigabyte of RAM.
But when maximum compression justifies that overhead, the payoff is massive. You can set a target compression rate to, say, 0.3. That means you are boldly stripping away 70% of the raw context. Just imagine running massive, complex, multi-turn agent loops, but you're only sending 30% of the tokens over the wire, all while keeping the exact instructions your model needs to succeed. It's a real game changer.
Okay, Section 4, Agent Wrapping and Endpoints. Let's look at how we actually route traffic through this in our day-to-day workflow. Honestly, transparently proxying any CLI tool is ridiculously easy. It's literally a one-step command. You just open your terminal, type Headroom wrap, followed by whatever tool you're using, and bam, you're done. The proxy instantly sits in the middle. Or if you're building a custom app, you can always just manually update the base URL in your code. Super flexible.
And it seamlessly mimics the provider endpoints you already know.
So your Anthropic or OpenAI calls, they just work. If you point your app at /v1/messages, Headroom knows to handle the Anthropic API format. Point it at /v1/chat/completions, and it perfectly handles the OpenAI format. Oh, and for those of you using the TypeScript SDK, these /v1/compress endpoint handle standalone compression without making any LLM network calls at all.
Of course, you absolutely need to know what you're actually saving. For observability, you get a whole suite of tools, from Prometheus-formatted metrics to live session stats, that store your durable savings right in a local JSON file. You can hit the Stats History endpoint to see hourly or daily rollups. It shows exactly how many tokens, and more importantly, how much money this proxy is saving you, so you can track it right against that daily budget we talked about earlier.
And look, if you ever need a raw, uncompressed response, maybe you've got a highly sensitive or super fragile prompt, there's an escape hatch. By passing a bypass header, you get a direct, unfiltered line straight to the provider. Just add Headroom bypass true to your request headers, and Headroom will cleanly step out of the way for that one specific interaction. Finally, let's ground this all in reality. Section 5, Production and Deployment, or Scaling the Proxy. Whether you decide to deploy via Unicorn or Docker, the setup is pretty standard. Just a quick heads up though, telemetry is on by default. If your company's security policy requires it, you'll definitely want to opt out. Thankfully, the developers made this incredibly easy to toggle off. You just pass the -no telemetry flag or use the environment variable, and you're good to go.
One quick pro tip for you Docker users. You are going to need build essential at install time. That's for compiling the C++ dependencies, specifically the HNSW live extension. But here's the cool part. Headroom smartly removes it right after the build to keep your final image nice and lightweight. It's just a really nice touch that shows the devs are thinking about the full life cycle of your deployment.
Ultimately, the future of AI development isn't just about throwing bigger, more expensive models at our problems. It's about building smarter, leaner pipelines. As your applications scale up, the efficiency of your token usage isn't just going to be some minor technical detail. It is literally going to dictate your profit margin. So take a hard look at your traffic today. How much are you paying for your LLM to read the exact same context over and over again? Are you ready to deploy Headroom and finally stop paying for redundant tokens?